Hi guys, this is topic 8.8, properties of buffers. The learning objective for this particular topic is to be able to explain the relationship between the ability of a buffer to stabilize pH and the reactions that occur when an acid or base is added to a buffered solution. It was mentioned in 8.4, but a buffer is a solution that contains something called a conjugate acid-base pair. And what they do is they maintain the pH of a solution when you have some acids and some small amounts of acid or bases added. The idea is that it helps maintain the pH of something. So sometimes, like in a fish tank, maybe not mine, I'm not sure, but there is a buffer that actually will help maintain the pH. Actually, yeah, the buffer is the effects of the nitrates and nitrogen from the fish poop. That makes sense. Cool. Another example of a buffer system is in our blood. The buffering capacity means that our pH doesn't fluctuate, and it allows us to not be into states of acidosis or alkalosis, where there's too much acid or base, if you will, in the blood. If an acid is added to a buffer solution, the acid will react with the base, converting it to the acidic form. If a base is added to the same buffered solution, for example, it will react with the acid and convert it to the basic form. This is related to Le Chatelier's principle, like we talked about last unit. And yeah. Consider a buffer that contains 2 moles of acetic acid, HCH3COO, and 2 moles of sodium acetate, NaCH3COO, and they're both dissolved in water. This is a buffered solution since both the weak acid and its conjugate base are present. So just so we're clear, here's my weak acid, and here that's my conjugate base. If 0.100 liters of 0.100 molar NaOH is added to the system above, it will react with the acetic acid and it's going to form its conjugate base as shown below. The NaOH is a strong base and is considered the limiting reagent. So we can assume that the reaction will consume all of it. So the idea is you have sodium acetate, the sodium ions here, and the Na right here. Those are part of the SNAP, the SNAP particles, if you will. Those are the ones that go into solution, and they're considered spectator ions, so you don't have to worry about it. So initially, I had 2 moles of acetic acid and 2 moles of sodium acetate. Adding NaOH, which is here, it produces, you will have your acetate ion, the conjugate base, and water. So the OH gets used up, so to speak, and it's going to be used up, and that's going to be consumed up by the reaction itself. So from there we can determine what are now my ratios of my conjugate base and my weak acid, which is seen right here in the equilibrium part of this ice chart. So by adding some base, there's very little effect on the ratio. It kind of stays around the same. That's the general idea we're going to get from this slide. Okay, so not too bad. Logically, it makes sense. Yes, I changed up the sound. Hashtag not sponsored by Sonic the Hedgehog and all that type of stuff. The same idea applies to adding an acid to a buffer solution. If 0.100 liters of 0.100 molar HCl is added to the original solution, it will react with the acetate ion and it's going to form acetic acid as shown below. HCl is considered strong and is the limiting reagent. So we can assume that the reaction will consume all of it, similar to before. So you have HCl, and the hydrogen that we're focused on, it is going to react with the conjugate base to form acetic acid again. Again, similarly to the other one, it changes by the same amount of the concentration for the moles of the hydrochloric acid. So it drops by that, making it 0, and the other one, the conjugate base drops by that as well, and the acid will increase by that to form that. So again, adding a small quantity does not affect the ratio for this. So complete the following table below with conjugate acids and or conjugate bases for the substance shown. So just so we know, a conjugate acid is formed when a proton is added, and the conjugate base is formed when a proton is removed from the original substance, whatever the case may be. So for here, my conjugate acid, by adding on an H to here, to this ion, I guess, by adding another H here, the overall charge will decrease by, I guess we'll go down to -1 or go up to -1. Yeah. H2PO4 1 minus. The conjugate base for this would be a phosphate ion. H3O plus, it doesn't have a conjugate acid, can't really add more to it. So this one is going to form water. You can imagine what the conjugate acid for this would be: HF, H2CO3 for this one. So you got some carbonic acid, and then over here the conjugate base will be carbonate ion. All right. So a buffer system, last slide guys, a buffer system composed of H2S and NaHS was created by dissolving 3 moles of each into 1 liter solution. Draw an image to represent the buffer system, including spectator ions. Don't need to include water. They provide a key for us. So this is my, weak acid, my conjugate weak base. So just draw the buffer system. So it says we have 3 moles of each. So if we have 3 moles of H2S, and since it's solution, we can't really group them together because they're swirling around and all that type of stuff. So separate them out, you should be good with that. NaHS, this breaks up into sodium ions and the HS 1 minus. So we need, I guess I probably could have done that, it's fine. 1, 2, 3 for the 3 moles. NaHS is 3 moles, but there's 2 ions there, so they actually will break up into 3. It'll be 3 moles of each. The molarity will be 3 molar. Write the reaction that would take place if a strong acid H3O plus were added to the system. So that means I have H3O plus being added. That's aqueous. So it's going to react with the weak base. Still aqueous. So what is my base going to do? It's going to accept a hydrogen from the hydronium ion, or from the acid. It's going to form back the original acid, H2S aqueous plus water. Write the reaction that would take place if a strong base were added to the system. So I have OH minus aqueous It's going to react with the weak acid. It's going to form the ion H. It's going to form the conjugate weak base and also water. So that's it for now. Let me know if you have any questions. Thanks.